Hello everyone. In this video, we are going to discuss about the optics of vision. There are various physical laws which is applicable to the visual system also, because it is also acting as a lens system and various layers or surface of the eye will cause the focusing of the light. So this optics of physics will help us to understand some of the refractive errors. So let's see. We are discussing our special senses under which the vision is being discussed now, and today's topic will be a visual optics. So let's get into the topic. So what is the physical properties of the light? That is very important for us. So first thing is, the light rays, they usually cause refraction whenever they pass from one medium to the other. In an optical system also, light is passing from the air and it is entering the various surfaces of the eye and finally reaching the retina to form an image. So whenever they pass from one medium to the other, what happens is there is refraction. And there is a specific term called as refractive index. This changes with various mediums, and whenever it is traveling in the velocity of the air, it is considered as the refractive index of 1. And for any other substances, we give the formula, that is the velocity of light in air divided by the velocity of light in that particular medium. So if a particular medium is changing its velocity, then that will contribute to the refractive index of the particular medium. And one more thing to note here is, whenever the light rays are forming a perpendicular to the surface of the any substances, what will happen is there is not actually bending of the rays. There is change in the velocity in the further medium. For example, this is the medium A, and if it is traveling in the medium B, there is change in the velocity. But if the rays are parallel to each other, there is not change in the bending of the light. Whenever it is an angulated surface, what happens is there is bending of the light. Both of this happens in the optical system of the eye. So coming to the optics of the eye, how does it apply? There are various surfaces and all of them have a different refractive index. So whenever any image is formed by an object, what is happening? It is traveling in the air, which has the refractive index of 1, and whenever it is at the surface of the cornea, the refractive index is around 1.38, and the aqueous humor, it is around 1.33, and finally the lens system, which is 1.40, and the vitreous humor is also having a different refractive index, which is 1.34. We don't have to remember the values, we are just understanding that light is passing through various different modalities in the eye. Now coming to some of the other physical properties of different types of lenses. For example, all of us know that whenever it is a convex lens, the term convex itself means that the light is converging. So if any lens system is able to converge the light and put it at a particular focal point, this is the focal point for this, then it is called as the convex lens because it is converging the rays. Whereas the concave lenses or the concave glasses does the opposite of the convex lens. What they do is they cause divergence of the rays. So what happens here? There is divergence of rays, as you can see here. Whenever the light rays is hitting a concave lens, it is going to get diverged. We are going to use these properties for the treatment of refractive errors. And there is one more property which happens in the cylindrical lenses. Whenever cylindrical lenses are used, what they will tend to do is they bend the light in one particular plane only. So if there is a refractive error in a particular plane only, then we are going to use a cylindrical lens. Then coming to the optics of the eye. In our eye system also, we have a lens. So what they are going to do is, they are generally converging the light rays. As you can see here, they are converging the light rays. And whenever all these light rays are converged to a particular point, that point is called as the focal point. It is also called as the principal focus. And a particular light which will not have any kind of refraction, that is, it is going straight into this focal point, is called as the principal axis. This axis, as you can see here, it is directly going into the principal focus or the focal point. This axis is called as the principal axis. And what is focal length? The distance between the center of the lens and the focal point, this length is called as the focal length. This focal length will help us to identify the refractive power of a particular lens. Whenever we are prescribed our eye spectacles, there also the powers will be mentioned. Usually it is mentioned as -2 or +2. Let's try to understand what is this -2 and +2. It is nothing but the refractive power which is indicated in the term of diopters. What is diopters? It means that this refractive power is 1 by focal length in meters. And what is focal length? It is the distance between the lens and the focal point, is called as the focal length. So how does the refractive power change? For example, the formula is 1 upon focal length in meters. if a particular lens system is able to converge it to a 1 meter distance. In this example, as we can see here on the bottom, it is mentioned 1 meter. So the first lens, that is in the above example, this, let's take it as A. This A lens is able to focus the focal point at 1 meter distance. So what will be its refractive power? It is nothing but 1 upon 1, which is equal to 1. If the power is more convex or the lens is more convex, what it is going to do? It is going to focus or converge it at a much earlier distance. So what does it mean? It has a higher power of convergence. So for example, in the second example B, if the lens system is able to converge it at a distance, half distance, that is 0.5 meters, what is going to be the power of the lens? The power of the lens is going to be 1 upon 0.5, which is equal to 2 diopters, which is nothing but 2 diopters. These are indicated with the symbol plus. What does this plus indicate? It means that they are converging the light to this particular distance. And finally, the third example, here you can see here the lens is much more convex in comparison to the above two lenses, and it is able to converge the light at a distance of 0.1 meters. So that is 1 upon 0.1, which is going to be a 10 diopters power. It is having an increased amount of convexity. As and when the convexity increases, the power of the lens is going to increase. Now coming to the concave lenses. Concave lenses, they are not going to put it into a focal point, they are going to diverge it. If a concave lens is diverging 1 meter, it means that it is just the opposite of a convex lens. So it is given as the negative diopter, that is -1 diopters. And most of the people like who are myopics, they will be given a concave lens. And concave lens, usually the power indicator is negative. And most of the people who are at an younger age, they are usually having the myopia and they will be given a negative lens. So in the next video, we are going to see about the refractive errors, and all these concepts will help us understand it better. So now coming to the concept of reduced eye. What is this concept of reduced eye? Since there are many refractive indices and many refraction happening in the eye, listing a scientist, what he did is he just gave us one concept, that whenever light is entering, it is getting focused. So instead of assuming at various different levels the refractive indices, he just considered the entire eye as one reduced eye. This is helpful for us to understand the focusing system of the eye, because we don't have to study it very individually for every single layer. And whenever we are devising some optical specs, it is also considering this concept of reduced eye. It is easier for the calculation. So one optical system with one nodal point, and he said that the radius of the curvature is around 5.73, and the power, the entire converging power of the eye is around 59 diopters. And it is very important to note here, the maximum diopter is contributed by the cornea. The cornea contributes about 2/3 of this entire 59 diopters. It's not the lens system. Of course, lens system is contributing to the 1/3, but maximum power of diopters or maximum converging ability is given by the cornea. That's why whenever you perform some of the surgeries for the refractive error, the corneal thickness is altered. Whenever you alter the corneal thickness, it is going to alter the curvature of the cornea, and it is going to correct the refractive errors. The human eye has a very special feature which is called as the accommodation feature. And what is it? It is the process of changing the curvature of the lens. So if I am able to change the curvature of the lens, then obviously the converging power of the eye can be changed. For example, a flatter lens is like this, and a wider lens is like this. Already we have seen that whenever there is a increase in convexity, they are focusing at a much earlier distance and helping in increasing the convergence power. The lens system also can change their shapes and increase the dioptric power. In a child, the lens system can contribute the dioptric power from 20 from its flatter state to the maximum of 34 diopters. Just by this accommodation feature, the child can increase the dioptric power up to 14 diopters. It means that it can converge it much higher whenever the convexity of the lens is changing. So how does it happen? Let's try to understand. Whenever the eye is in a relaxed state and it is focusing an object from a distance, usually the lens system is flatter. How does this happen? Because here the ciliary muscles are not contracted. So whenever the ciliary muscles are not contracted, what happens to here is the suspensory ligaments keep the lens in a taut state, like in an elongated state. But what happens here, as we can see in the next diagram, if we want to accommodate, what will happen? The ciliary muscles will contract. The ciliary muscle is going to contract and come closer from its previous position. So it is coming closer from its previous position. So when this happens, what is happening is the ciliary muscles are coming closer. So the suspensory ligaments which were keeping it taut, now they are coming closer. So what will happen? They have become loose. Whenever the suspensory ligament becomes loose, the lens, because of its inherent property to become more convex, what it is going to do? It is going to become more convex, and the convergence will be much better in case of a accommodated eye. So when does this need to happen? Whenever we are seeing a distant object, that is not going to be required. So but whenever we are trying to accommodate for a nearby object, what is going to happen? The lens system is going to increase the convexity and more convergence will happen, so that the light can be exactly focused at the retina. And this is always under the control of parasympathetic system. The parasympathetic system is the one which is contracting the ciliary musculature. This accommodation of the lens, usually what happens is at an younger age, it is having a very good accommodation power. As and when the person is aging up, what is going to happen? This accommodation is going to be lost, and this condition is called as presbyopia. This condition is called as presbyopia. And in an infant, as we already saw, from 20 diopters, it can increase up to 34 diopters just by changing the curvature of the lens. So in the infant, it is around 14 diopters. When the person is around the age of 45 to 50, it is 2 diopters. And when the person is aging around 70, it is usually 0 diopters. That is, the accommodation is completely lost. And to treat the older people with presbyopia, we generally use bifocal lenses. One is for the distance vision and another one is for the near vision, because for the near vision, the accommodation is completely lost. So these are some of the properties of optics which will help us to understand better the refractive errors. We will see in the next video of refractive errors. Thank you for watching the video. Subscribe to the channel for more such content. Thank you so much.